Welcome to XL Catlin Arctic Live, broadcasting from the UK Arctic Research Station here on Jollasund in Svalbard. And welcome to the final session this year. It's been an amazing time so far, speaking to thousands of young people around the world. Great to welcome 20 schools from across the USA and Canada. We have Mr. Plant's class from Ontario in Canada, and Miss Nicodem's class from Pennington Middle School in Virginia. So thank you very much for being part of this call. We've also got the chance for you to submit questions via the live chat, and that is on the Digital Explorer YouTube channel. So please join in there. As I have mentioned on previous calls, we're up here on Svalbard doing two things. We're doing a little bit of science and also some outreach. The science that we're doing is looking at microplastics and ocean acidification in the fjord waters here, and that's the Arctic Ocean, Atlantic Ocean coming in through the sea inlet behind us. It's a little bit snowy out there at the moment, so not, unfortunately, not so much to see. Microplastics, those are the tiny plastic fragments that can get into the marine ecosystem, can be eaten, ingested by small plankton. So we've been looking at how many there might be here and where they might be in the ocean, so on the surface or further down through the water column. Secondly, looking at ocean acidification, we have been looking at that concept, which is where excess or increased levels of carbon dioxide in the atmosphere are absorbed into the ocean and change its chemistry, lowering its pH. Now, that lowering of pH can affect a range of different animals that live in the sea. We've been looking both at monitoring how the ocean chemistry is changing and setting up an experiment to look at how that affects different types of animals, whether that be those animals which make their structure or shell from calcium carbonate, a type of mineral whose availability is affected by ocean acidification. And we've also been doing the outreach, and it's great to have questions coming through and questions sent in advance. These from Mr. Plant's class in London, Ontario in Canada. We have a question from Rhett. How much glacial ice has disappeared because of global warming? Rhett, it's a great question, and it's a question we don't quite know. We can measure it in different ways. So we can measure the amount of runoff that has come, so the amount of meltwater that's coming off a glacier. But very excitingly, there are new techniques being developed to measure the volume of a glacier. So what you can see from a satellite photograph is how glacial regions might be retreating in terms of area covered by glaciers. But what we don't know is what the volume's like, and to measure the volume of a glacier, we need to use new radar techniques. So whether those are dragged across the surface of a glacier or whether those are airborne. So it's a great question, and we will get better as a science community at working out how to measure the volume of glaciers around the world. Kiara is asking, if all the Arctic ice melted, how badly damaged would the world's coastal cities be? That's a great question, Kiara. So a lot of people live in coastal areas. If all the ice were to melt in the Arctic, the sea level would rise by about 6 or 7 meters, and that's about 20 feet. So if you think about how that might affect people living in coastal areas, if the ocean, the sea, were 20 feet higher. Now, if you add to that all the ice in the Antarctic, you'd then see a sea level rise of about 70 meters, 60, 70 meters, and that's about 100 80, 200 feet of sea level rise. So that's fairly dramatic if you think about it. How many places around the coastal regions, any major city by the coast, would be swamped? So how badly damaged would the world's coastal cities be? The answer is pretty badly damaged, and there's some great maps that have been made showing the impact of this level of sea level rise. And Kiara again then asking, so if all this Arctic ice melts, how many people would lose their homes? You know, you have an increasing number of people in there who are living in coastal regions, who are living in coastal cities. So we're talking potentially millions, if not a billion or more people who would lose their homes. I'm going to take a couple of questions now from Pennington Middle School in Virginia. Welcome back, and thank you for connecting with us once again. So here we have the first question. How many years have you been going to the Arctic for research? This is my 6th trip to the Arctic for research. The first one was in 2011, working on the Arctic sea ice in the high Canadian Arctic. And then since 2014, I have been coming and joining research programs here in Njalsund in Svalbard, looking at a variety of different things: ocean acidification, glacial microbiology, how the inside of glaciers work, the channels that cut through the inside of a glacier, and now working on microplastics and ocean acidification again. So another question from Pennington Middle School in Virginia: what has been your favourite or most interesting research project in the Arctic? Wow, a great question, and so many to choose from. Definitely have a soft spot for the first program I worked on, and that was looking at copepods, a type of really important plankton, and they form the basis really for the entire Arctic ecosystem. So they turn in the algae into sort of basic proteins, and so those are then going and building other animals. So copepods get eaten by fish, fish by seals, seals by polar bears. So really crucial. We were looking at how future changes in ocean chemistry might affect copepods. So that was a really fascinating bit of research to be involved in. And also, interestingly, it was a piece of research where the sort of weather has been most extreme. So we had to, it was a really sort of bonding experience because of the extremities of the weather. So that's probably up there with my favourite research program in the Arctic. And then moving on from that, another from Pennington: other than the cold temperatures, what are some other challenges you and your team face when in the Arctic? Well, the cold is definitely a big challenge, but it's also the isolation. If you forget something or something breaks, you're very, very far away from getting a replacement. And so it's really important that you have your sort of MacGyver skills with you, that you can work around these problems, you can find solutions using whatever you can find lying around, not quite lying around, but the ability to fix things and find alternatives is really, really important. Every trip I've been on, something has not gone according to plan, and we've had to find a way around it. Everything from, I've built sort of duvets and sleeping bags for electronics, to finding different ways of deploying experimental units. So always experimenting. Again from Virginia, how many years did you teach at school before you began travelling as a researcher? What grade and subject did you teach? I taught for 5 years, and what grades and subject I taught? I'm going to translate this. Perhaps you can help translate this. I'm never very good at doing ages to grades. So I taught from age 11 to 18. and I think I'm not even going to try and work it out. So that I think it's 12, so like grades sort of like 6 to 12, something like that. And I taught history, geography, citizenship, law, religion, and sort of did sex and relationships education as well. So essentially, probably more sort of social studies side if we're coming from this sort of American angle, those kinds of topics. Back to London, Ontario. Do you use fridges to store your food, or do you store it outside in the ice and snow? That's a really great question. We do use fridges to store our food. We also use fridges to store our science. So within the research station, there are a couple of freezers and a couple of fridges to store scientific samples at a sort of a nice level temperature, just so they aren't disrupted. It's really, really important that because those aren't going to be analysed for several weeks now, those are kept really stable and at the right temperature so they don't degrade, and then we can get those into the lab in the UK and do further analysis. But in terms of the food, that's all in big fridges. The temperature can fluctuate here really wildly. When I was here last March, we had a sort of 20 degrees Celsius, and that's a sort of 36 degree Fahrenheit change in temperature just between 2 days. So you can't quite trust leaving stuff out in a big box in the snow. I have done that on other expeditions, but currently in Svalbard, not quite possible. So, Ewan, have a shout out. There you go. Hi, Ewan. What's your greatest hope for your science that you have completed so far? I think it's really interesting when you look at doing science in the Arctic. And from an outside point of view, what you want is that sort of like that big picture. But the questions you're asking as a scientist or working with scientists are often quite small, so it's like making a jigsaw. So I think my hope for this research is that it forms an important part of that overall jigsaw of understanding how the Arctic is changing and understanding what human impact, what human activity, what effect that is having on the Arctic. And when we start to know those things, then we can start to take action in an informed way, both on an individual level and on a governmental level. So those are the things that, those are my hopes, if that makes sense. We have another question from Pennington Middle School. What is the most interesting thing you have seen on this expedition? Wow, so I think the most interesting thing that the team have seen must have been the beluga whale and the walrus. So great to see some of the fantastic marine mammals in this part of the world. And it's one of the great privileges, you know, you come and do your science and you do the outreach, but being here, being close to sort of animals that you sort of dream about seeing, that you think only exist on, you know, a TV show. For me, watching people like Sir David Attenborough present, I never thought I'd be able to see those animals with my own eyes. So that's been amazing. We've got some questions coming through also from Eagles Landing Middle School in Florida. What's the most interesting piece of research that you discovered throughout the years of working with scientists? I think that going back to that question, the really interesting paper published by doctors Finley and Lewis on how different species of plankton respond in different ways. So I think we think about these environmental problems as just being, you know, it's going to affect everything equally, but finding out that, you know, the real So science is more complicated than that. And they were looking at two different types of small animal that lived in the Arctic, and finding that in fact they had different responses to changes in the environment. So I think that's really interesting. It's not a blanket answer that science could give, but it's always quite nuanced and looking at the detail. Again from Eagles Landing Middle School, when did ocean acidification start, and what is the trend now? Really great questions. So ocean acidification is said to have started sort of in the 1750s with the Industrial Revolution, when you have more carbon dioxide being produced and going into the atmosphere. There's a natural process called buffering, which has kept ocean pH sort of roughly stable. So what we're looking at the moment is the fastest change in ocean chemistry for the past 300 million years. So it's a fairly sort of rapid time for us. And since 1750, over the past 250 years, we've seen a drop from an average ocean pH of about 8.2 to about 8.1. Now that 0.1 of a unit may seem like a tiny amount, but it actually represents a 30% increase in acidity. So as pH goes down, that represents an increase in acidity. And that increase in acidity is starting to affect some animals. There are changes, there are variabilities across the world. In terms of the trend right now, I don't have the latest papers to hand. I know that the Hawaii Ocean Time Series data is great for looking at. I mean, that's been going since, I think, the 50s or 60s. And that's great looking at trends in the modern era. In terms of Kongsfjorden, it's some of the measurements that we're taking at the moment. Again, here we go from Eagles Landing. How much do we actually know about the marine life? Are there undiscovered species? We know very little about the oceans. I think that's what makes it so exciting. There are stacks and stacks and stacks of species that are unknown to science. And so very exciting to try and discover some of those. You know, a friend of mine and his organisation went to look at a seamount, that's an underwater mountain off Bermuda, and they found over 100 new species in just 6 weeks. So there are stacks of new species out there. It just takes time to explore. Moving to St. Louis School in Leamington, Ontario. An amazing question: how many scientists are currently researching the Arctic? I've got no idea. There's 100 people in the Olafund at the moment, but probably many hundreds of scientists across the Arctic region, whether they're based on ships, based at other research stations in Greenland and Alaska and Canada and Russia. So, amazing question. So what other research goes on here? There's glacial research, there's research into bird life, there's atmospheric research with the glaciers, there's the physical research in the glaciers, the microbiology, there's soil studies. There's a whole host of different studies going on to look at the changing Arctic and what we can learn from this amazing place. Another interesting question: how can scientists make predictions about the future of the oceans? It's a really interesting point. So what scientists do is something called modelling, and that means they try and look at all the different factors that can alter the oceans. So that may be increased carbon dioxide in the atmosphere, that may be different ocean currents, and using historical data to try and sort of build patterns and understand how these might work. And then you set it to run into the future. Based on what you've observed in the past, you can start to make predictions. And where it's more complex, you're using a computer to be able to do that. And so, you know, how do scientists make predictions? It's through getting a lot of data about what has happened, and trying to create a model that respects that data and is in tune with that data, and then allowing to sort of think about what might future conditions be like, and then model how the ocean might be changing. And we have how do scientists know how many samples they need to take to make reliable conclusions? Another really great question, and that again is a tricky thing. Obviously, you'd want to take as many samples as possible, and that's what we've done over the past 2 weeks here in the Arctic. But you could almost survey the entire Arctic Ocean looking for plastics. There is obviously a resource limitation there. So scientists look at, well, what is a good amount? What is a representative amount? If I trawl for plastics for 2 minutes, does that give me the right amount or a good amount? If I take trawl for 10 minutes, is that a better amount? How many times do I have to trawl for plastics in the same place? And there's some sort of agreed standards that seem to show that if you take this amount of measurement, that is going to give you a representative idea. So at the moment, that's about 10 to 20 minutes per trawl and 3 trawls per area. And then we go and we trawl in 6 different places across the fjord. So it's really working to get that representative example. And you're also, when you write up your science, making sure that you are describing your methodology and making sure that other scientists know how you're doing it. And then you can all develop it to make it more accurate and more accurate. It also means, as a layperson, as somebody who's following that science, you can go and you can see how a scientist has done something. So there are a certain sort of like agreed sampling procedures for different types of science. That is a great question. So where are we? Miles Boggs, how many species of penguins are in this area? Another great question coming there. I'd love to get some ideas from those watching about the number of penguin species in the Arctic. And if you could name a species of Arctic penguin, then we will post one of these reindeer antlers to you. So please, I think we have, how many antlers do we have here? We have 4, so we've got enough for 4 schools to win a reindeer antler straight from the Arctic by naming a Arctic penguin species. So we'll see what's coming through on the live chat. So we have another question here. Have you noticed any plants or animals having to adapt from global warming? At the moment, it has been noticed that there's behavioural adaptation in the polar bear because of global warming. Ordinarily, a polar bear will hunt for seals, but it's been noticed that they're starting to hunt for goslings, for baby geese, and to eat goose eggs as well. And you might say, oh, well, no, they're still getting food. The sea ice is gone, which is a hunting platform for the seals. But that's a different sort of, if you equate it to human behaviour of moving from eating sort of a whole sheep to having scrambled egg for breakfast. And so it is putting a lot of stress on the polar bears who are forced to do that, and they have to expend probably more energy in getting their food as well. Have I ever been attacked by a polar bear? No, I have never been attacked. We haven't had any polar bear encounters this year, which is in some ways is reassuring, because it's you don't want to have to be faced with a polar bear, the largest land carnivore. But in other ways, it would be great to be able, from a safe distance, to see one of these wonderful, wonderful animals. And I see that the team in London has put in a spoiler alert, who've crashed my guessing game that there are in fact no penguin species in the Arctic, and if there are, then they're very, very, very lost. I don't know whether there are any sort of in a zoo or something there. Emperor penguins, gentoos, king penguins, chinstraps, Adelie, all down south, all at the other end of the planet. I think there are only a tiny colony of penguins in the northern hemisphere, and they're on one of the islands in the Galapagos, just peeking over the equator. The only penguins in the northern hemisphere, apart from the ones in zoos, obviously. Only place where penguins and polar bears might meet is the zoo. So thank you very much, Sophia. We are coming back to the UK tomorrow, as long as the weather doesn't come in overnight. So the weather forecast is looking good, and so we should be back in the UK tomorrow evening. Miles from Pennington would like to know how deep the snow gets. It actually probably doesn't get as deep as some places in the northern US and Canada. That's because technically Svalbard is a desert. It receives about the same annual rainfall as the Mojave Desert. And so any deep snow we get is because of drifting snow. So you could get drifting snow many, many meters deep. But the sort of average snowfall, and there hasn't been that much snow this year. So we've had the melt, or the melt start over the past week or so, and we've seen the snow disappear pretty rapidly. How much does it snow annually, and what is the temperature right now? The annual snowfall in Svalbard, I would have to look up, but it is starting to rain as well in Svalbard, and the temperature right now is around 0 degrees, so not too chilly at all. So it's been really, really wonderful to have these questions coming through, and I think we've got a couple more here, and these are from a previous live chat that we didn't quite get to, but I've just seen that we have some coming more from Colton from Pennington. Have you found any fossils in the snow and ice? No, we haven't, but this is a great fossiling part of the world. Very rich seeds of fossils, so do come up here. I think there have been some famous dinosaur finds in the Arctic. So if you're into dinosaurs and cold places, head to the Arctic to try and find those. We have the questions that came through beforehand. We've got some. Here we go. From your experience, what is the best way to keep warm in the Arctic? That's a great question. So as you can see, I'm wearing several layers here. I've got a base layer, fleece, and this warm outer jacket. And it really depends on what kind of activity you're doing. Just beside me are some boat suits. So if you're out on an open boat, then you need to be wearing a boat suit just in case you fall in the water. If you're working hard, you probably don't want too many clothes on, just so your perspiration can get out. If you are at sort of -40 and you really need to stay warm and you're not taking huge amounts of exercise, having a big down jacket is also really important. Nice big fluffy down jacket. Having proper gloves, different layers of gloves, so a thin layer to go over your hands, potentially then a medium-sized pair of gloves, and then mitts over the top of those. So up to 3 pairs of gloves, 3 pairs of socks, 3 pairs of sort of everything. It seems those layers just to keep warm. This is an interesting question. It's really sort of looking at why we're conducting our research in the Arctic rather than penguin country down in the Antarctic. And the polar regions are both, both polar regions are really, really important. I think that for the Arctic, it's really ease of access. So we can come up here for 2 weeks. We've got 1 day's travel to get up here. And we can come up here and study this sort of pristine environment or remote environment really, really easily. Going down to some of the remoter bases in Antarctica, it can just take weeks to get there, let alone do your project. So people are often there for months at a time. So the Arctic is much more accessible and allows us to be able to research this sort of polar regions and find out how they're changing. Great to see, how do you travel in the Arctic? Is it by snowmobile or dog sled? So the way that we travel around here really depends on what we're studying. Some people do have dogs up here, and there are a couple of, there's a small dog team, I think, being kept in one of the pens. But for the most part, we're getting around by snowmobile or skidoo if we're going on the glaciers. And then if we're out on the waters, on the ocean, researching out there, then we're out in a boat. Either a smaller boat, a polar circle, or a larger boat with a cabin, which is really nice when the weather gets a bit horrible, so you can get into the cabin in between sampling. We have Sophia from the Landmark International School. Great to have you back, and thank you so much for your great questions beforehand. Ewan looking at are the beaches full of plastic? At the moment that we haven't seen really sort of that much sort of litter on the beaches. Apparently that comes a bit more in the summer, so we can wait and see. There has been some research published last year, some Dutch research, looking at the amount of litter on Svalbard beaches. So it does occur, but we haven't seen it when we've been up here. We have Sheridan Hill in Clarence, New York, asking what future expeditions are you doing? When are the next live events? And what's your who is your favourite explorer? Wow! So future expeditions, we are involved in some coral work and some plastics work, and so we'll be bringing those live to you. I think that is broadcasting from, let me work it out, October, November for Coral Live, and then the spring will be Plastic Live, and then we're back in the Arctic, I think towards the end of April, beginning of May next year. So there's a packed calendar of live events for you to join in. And favourite explorer, wow. So just thinking about that, I think, there are some wonderful explorers out there. I have a sort of a fondness for someone called Francis Younghusband, who did some amazing journeys where I first started exploring in Tibet and in northern Pakistan. He also did a lot to on the sort of hippie-ish, 1930s hippie-ish thing, so trying to bring sort of more of a gentler attitude into 1930s life. So he had those twin aspects to him, but also love Sylvia Earle, who is also known as Her Deepness, who's been an amazing ocean explorer, submersible engineer and pilot who has really pushed the boundaries. So Francis and Sylvia, there we go, are truly inspirational explorers. Sophia, and here we go. So Colton, sorry, do you do a lot of dissection in your research? Not a lot of dissection. There are a couple of crabs who are going to be inspected for microplastics. But the focus here has been a lot more about sort of trawling through and not necessarily about dissecting animals. So it can be, depending on what you're looking at. I think we'll do a lot more dissection. We're looking at some plastics projects later in the year. We're looking at more dissection and looking at how animals have been affected by plastics. Sophia, do you ever miss people when you're on expedition? Yes, big shout out to my family at home who, fingers crossed, travel goes well. We'll see you tomorrow. Gabe at Pennington, what happens if one of you gets hurt? Is there medical care nearby? It depends what you mean by medical near and medical care. So most of us are first aid trained, varying levels. So that's normally an expedition first aid course rather than your standard one for sort of life in cities. You then have a dispensary. So if you need to get some medicines, you can call up the doctor, who's half an hour flight this way, and the doctor might agree to prescribe you something over the phone. So the nearest doctor is half an hour's flight in a helicopter. And then if it's really serious, the doctor would come up here and examine you. If it's really serious, more serious, then you would get in the helicopter back to the doctor. And if it's super serious, then you need to go to hospital, and that's another flight to the mainland. So we are quite remote. So yes, there is a level of medical care here, but the nearest hospital is a helicopter ride and then a flight on a jet away. Jace at Pennington, what is the water temperature? Great question. It's between about 33 and 31 Fahrenheit, depending on the depth. So you can get water temperature below freezing, and that's because of the salt content. So the salt content of the water here in the fjord is about, well, it's basically 35 grams per litre of water. What advice do you have for young scientists like me? Great question. So, stay curious, follow your passions. You can be a really great person involved in science without becoming a professional scientist. There are lots of other science-based careers out there. I think just be passionate and curious. If you want to be a field scientist, if you want to come to places like the Arctic, get outdoors. Get outdoors with your friends, with your family, through organised groups, and spend time observing nature and recording that, and read some of the great naturalists and travellers. Certainly, who've inspired me. I think Sir David Attenborough's, Jane Goodall's work, great role models to follow. Going back to Sheridan Hill and Clarence, New York, what's the most remote area you have visited? I suppose, it's pretty remote here, but I suppose even more remote was when we camped on the sea ice off Eleth Ringnes Island, and that was in Deer Bay, and that is basically at the top of the Canadian Arctic archipelago. So if you look at a map of the world, you see all those little islands at the top of Canada. We were sleeping on the sea ice just off one of those up there. So that's pretty remote. And the nearest other person was 400 miles away. Where do microplastics come from? That's a really good question. So where do they come from? They can start as small particles. They can start as particles that come off your clothing when you wash it. They can start as small particles when you have microbeads in cosmetics. They can start as small particles sometimes through the beads that are part of the plastic manufacturing process. But more often than not, they are larger plastic items that have become more brittle in the ocean environment, and then the wave action has sort of smashed them into smaller and smaller pieces. So the microplastics are often quite old plastic as well. It's been in the ocean for a long time. And is there a way we can clean the ocean from microplastics that have been accumulating? It's going to be incredibly resource intensive to clean the oceans of microplastics, and maybe the best way to do it is to stop microplastics at source. So we can go through the different ways that might happen, or perhaps you can do a plastic audit of all the plastic that you use at home or at school, and start to think about how you might work through that and reduce, especially some of your single-use plastic. So making sure that, buying, that bottle of water from a convenience store, drinking it and then throwing it away, not a great use of the incredible substance that is plastic, because it does last for such a long time. Are you only doing oceans education? What else is Digital Explorer doing? Wow. So no, we're doing more. I mean, with plastics, there's other aspects of that. We've got a coding education program called Code Smart, learning how to code robots, and that's looking at autonomous vehicles as well. We have a school linking program with refugee schools in the Middle East, My Voice, My School. And coming up, we've got a couple of very exciting programs I can't quite tell you about yet. They haven't been made public, but there's sort of creativity and science running through those as well. So do register on the Digital Explorer website. That's for teachers. Register to keep in touch with all the programs that are coming up. And we have published an album on our Facebook page. So if you'd like to share photos of the journey so far across the Arctic, please go to the Facebook page and share those with your students. It's been a massive thank you to a great many people and organisations for making XL Catlin Arctic Live possible. Big thank you to someone who probably name you won't have heard yet, Mariuka, who has been doing sterling work back in the office in London, making sure all your questions get answered, or as many as possible, and helping you get onto these live broadcasts. Big thank you to Ellie, who's currently behind the camera, our field producer here in the Arctic. Thank you to the scientists and to Nick Cox, who's our station manager. And a big thank you to our sponsor, XL Catlin, our science partners in the University of Exeter and Plymouth Marine Laboratory, and to the British Antarctic Survey, who support us getting to the Arctic and working here, and to the Natural Environment Research Council, NERC, who fund this amazing station that has been our home for the past 2 weeks. And thank you to all those teachers and educators who've got their classes engaged with Arctic Live, and to the students who've sent through their questions. So until next year, it's a big goodbye from the Arctic, and thank you. Bye-bye.